In this lecture, I'm going to tell you about the transient analysis in network theory subject. So it will be very important topic for GATE exam. So we will get at least every set will get 2 to 3 marks. 1 mark question and 2 marks questions. One mark question, 2 marks questions. Pakka will be there. Then, so first I will introduce what do you mean by transient, then the behavior of these components. So how the resistor will behave, how the inductance will behave, and how the capacitance will behave. Now, the transient, only 3 concepts will be there. If you know that concepts, the transients part will be over. That is, how the components will behave at t equal to 0 minus, at t equal to 0 plus, at t equal to infinity. When you know how the components, elements work in these 3 time conditions, that is 0 minus, 0 plus, infinity, then this transient concept is very easy. We'll easily solve in the GATE exam. Now we'll see how these components will behave. Now, whenever we give some DC voltage, that is sudden rise in voltages, the resistor will allow all sudden changes. There is no stopping the values. So always the resistor will allow any changes at the instant of time, right? So we don't require the resistance concepts when the transient is happening, right? Now only 2 elements or components will oppose the sudden changes in the circuit, that is inductance as well as capacitance. Now how it will behave, right? So again I'm telling, the inductor and capacitances will oppose sudden changes, right? Now how we'll see. Suppose, before that we need one more concept. The resistance always, it will dissipate power, right? So whenever we give voltage or whenever we passing some current, it always dissipate the power. But in the case of inductor and capacitor, inductor stores energy in terms of magnetic field. So magnetic field is like, it will store the energy in terms of a current, right? That is about the inductor. Similarly, the capacitor stores energy in terms of electric field. So electric field, which is nothing but in terms of voltage. Alright. Now suppose when we give sudden changes, so it opposes sudden changes now, but when you keep on applying the voltages or current, so it will stores energy up to infinity of time, right? Now see, inductor is storing the in form of current. Now we are applying voltage up to infinity time. So at steady state generally, or at infinity, the inductor will behave like a short circuit. Why? Because whenever there is a short circuit, the current is a maximum current. So I is maximum. That means it will store maximum amount of energy at infinity time, right? Now similarly, the capacitor, says capacitor stores energy in terms of voltage. That means when we are applying the voltage of continuous up to infinity, now whenever the capacitor is fully charged, so it will behave like a open circuit. That means the VC of infinity will be there. That is a maximum of the voltage at the infinity time. Similarly here, the short circuit behaves, the maximum current is flowing whenever it is short circuit. Maximum voltage will be stored when it is an open circuit, right? Now we will see what is this 0 minus, 0 plus for the inductor and capacitor, right? Now see, the always we have to look for the impedances. So the equivalent circuit for this one is in terms of impedances S into L, that we know already. Similarly for the capacitor, it is like 1 by S into C. Now I told you at t equal to 0 minus, that means from minus infinity to 0 minus, we are applying the voltage or current to the inductor. That means it is reached to steady state. That means it stores energy in form of a current. So it will behave like a short circuit at t equal to 0 minus inductor. Remember this point. Next, at t equal to 0 plus, that means at t equal to 0, suppose I applied a sudden change in the voltage or current, or a sudden voltage I applied across the inductor. That means it should oppose that variation, right? That means it should behave like a open circuit. That means whenever there is open circuit, no current flows. That means it is not allowing the current. So that's why it will behave like a open circuit. Now the last one is t equal to infinity. That means we keep on applying from 0 to infinity the voltage or current. That means it reaches to steady state. That means it stores the maximum current. That means again at t equal to infinity, the inductor will behave like a short circuit, right? But in these three cases, we need to see one more thing, that is this is called I of 0 minus. That means this current is flowing at t equal to 0 or t equal to 0 plus. Now the current, whatever it is stored, that should pass. So that means there will be a current source of I of 0 minus. That means at t equal to 0 plus, so I of 0 plus is nothing but I of 0 minus, and the equivalent circuit is like this. At t equal to 0 plus, the inductor will behave like an open circuit, but already some stored energy is there in form of current, so it is storing that. That is I of 0 plus is equal to I of 0 minus, right? Now the at t equal to infinity, it is like becoming a short circuit. Again there is a I of infinity, which is at infinity time, what is the maximum current it is flowing in the inductor. So this is like about the inductor. At t equal to 0 minus, it will behave like a simply short circuit, and the current is flowing I of 0 minus. At t equal to 0 or t equal to 0 plus, whenever we apply some voltages or current, it will oppose sudden changes. That means it should behave like an open circuit. But already some current is flowing, that current should be there. That's why parallelly there is a current which is I of 0 minus is equal to I of 0 plus. Again at t equal to infinity, again it will reach to steady state. So there is a current of I of infinity. Now similarly for the capacitance, how it will be. So it is like opposite. At t equal to 0 minus, the capacitor is reached to steady state. That means the open circuit of the capacitor, right? So whenever it is open, what is the condition? Vc of 0 minus, it is stored some energy in form of electric field or voltage, that is Vc of 0 minus. It is at t equal to 0 minus. Now at t equal to 0 plus or t equal to 0, that means the moment we apply sudden change at t equal to 0, it should oppose. That means it will behave like a short circuit. But already some voltage is there, so that voltage will be in series. That is, this voltage is called Vc of 0 plus is equal to Vc of 0 minus. That means whatever is there, the voltage at 0 minus, that also will be equal to at t equal to 0 plus, and this capacitor will behave like a short circuit at t equal to 0 plus with this voltage, right? Again at t equal to infinity, that means it is reaching the steady state. That means we are applying up to infinity time the voltage. That means it will reach steady state. Again it will behave like a simply open circuit, and the voltage is we know as Vc of infinity, right? So this is how the capacitor and inductor works. T equal to 0 minus, 0 or 0 plus, and t equal to infinity. Once you know this concept, you can apply in the given circuit, and we can find Vc of t for t greater than 0, IL of t for t greater than 0, right? And IL of 0 plus, IL of 0 minus, VC of 0 minus, VC of 0 plus, and so on. But before that, we need these two concepts, right? I hope you got some idea about how the inductor or capacitor behaves at these three conditions, right? In the next lecture, we will see from the different circuit of inductance. Now it's like a source free circuit with the source, etc. How to do or how to solve those problems, right? In this lecture, we are going to analyze in depth for only inductor. In this lecture, we will see only for inductor how it will behave like when we give a DC voltage. Now remember, in the transient, generally what do you mean by transient? So transient state generally is called uncertainty. That means suppose when I give some voltage, DC voltage to an inductor, it will oppose that voltage. That means in that the moment when we apply some sudden changes at that instant of time, so we don't know what is the state of the inductor, right? So that is called the uncertainty, or generally we say transient state. So in inductor there is a transient state and there is a steady state. So steady state means when you apply this voltage continuously up to infinity time, the inductor will reach it's a steady state. That means at the steady state the current will be definite. That is generally we take it as IL of infinity, right? So transient state as well as steady state. So transient state is like an uncertainty state. The steady state is the final state, or it is called a stable state, right? At the stable state we will have a finite values. Now in the previous lecture we have seen how the inductor will behave at t equal to 0 minus and t equal to 0 plus, t equal to infinity. I told you at t equal to 0 minus, it is nothing but minus infinity to 0 minus. That means it is reached its steady state. That means the current should be finite. So that current I am taking as the IL of 0 minus. And the next is t equal to 0 plus. That means after we apply the voltage, right, at t equal to 0, the next moment what will happen? So the next moment the inductor will oppose the sudden changes. That means it should behave like an open circuit. So open circuit means there is no current, but already it is stored something that should be, we have to take the finite value. See, whenever there is a uncertainty, that means we should take some finite value. That we will take is the previous value. That previous value is nothing but IL of 0 minus. So at t equal to 0 plus for inductor, what is the present value is always equal to the previous, that is IL of 0 minus. The next one is t equal to infinity. That is again it is reached to steady state after we switch closed or t equal to 0 when we apply some voltage. So that is represented by IL of infinity. And remember, the energy stored in an inductor at instant of time, it is nothing but half L into I square, right? If it is at t equal to 0 minus, half into L into IL of 0 minus whole square. If it is at infinity, it is half into L into IL of infinity whole square. Because of time, I am not going for the in-depth analysis how we got the energy stored like half Li square like this, right? So you can remember half into Li square is the energy stored in the inductor at instant of time. It may be 0 minus, it may be infinity, right? Next we will see analysis. When inductor is connected in a circuit, how to analyze. Now see, when you observe this circuit, there is a switch. The switch is closing to position 1 and position 2. At t equal to 0, this position is changing to 2. That means in the previously it was at position 1. That means we have to analyze in 3 different conditions. T equal to 0 minus, 0 plus and t greater than 0. Now I told you at t equal to 0 minus, the inductor will behave like a short circuit. So in place of inductor, we are making a short circuit. But this switch position we have to see. It may be given in the question, or it may be we have to assume like this. Whenever this arrow is downward, that is position 2, that means it is already in position 1 for longer time. So whenever it is position 1, so it will become like this, and resistor R, and the inductor will behave like a short circuit. Now if I take this value, IL of 0 minus is nothing but V by R. Only V and R is there. What is the I? V by R. Now we know IL of 0 minus. Next we have to see at t equal 0 plus. That means this switch is suddenly closer to second position. That is the source we are removing. Now I told you whenever t equal to 0 plus that this inductor should behave like an open circuit. That means it is opposing the sudden changes. But what is the previous current? It is IL of 0 minus. So IL of 0 plus is nothing but IL of 0 minus, which is nothing but V by R. So already we defined it. Now the next case is t is greater than 0. So t is greater than 0 is same as this, but inductor should be there, and the inductor initial current is IL of 0 minus should be there, which is nothing but V by R. Right? So this is the three different conditions. Now we will see how to find the current expression for t greater than 0. So for that we need some basics about the differential equations. I hope everyone knows. Now for t greater than 0, this is the circuit we should take. There is R, there is an inductor L, this is IL of t, this is L, but initial current is there, which is nothing but IL of 0 minus, which is V by R. Now it's very simple. We need to write an expression. Now remember, if there is an inductor, what is the current expression? IL of t is nothing but 1 by L integral VL dt. If I need VL of t, it is nothing but L into DIL by dt. So we have to remember these two expressions in terms of inductor. Now if I am applying this KVL across this loop, so it is touching with the R, so R into IL of t plus, now I need a voltage, so this is the expression for voltage, so L into DIL by dt, which is equal to 0. Now it's very simple. It's looking like a first order differential equation, and we can go for variable separable method. That is R into IL of t is equal to minus L into DIL by dt. Right? Now DIL is here and IL here. So I can take this IL that side and this dt and L this side. So it will become minus R by L dt is nothing but 1 by IL into DIL. Now what is the next procedure? We have to integrate, and there is a constant plus k. Now this is the constant. I will get minus R by L into t is equal to 1 by x, nothing but ln x, so ln IL plus k. I need IL, so what I will do, that k I will make this side, so this will become minus, plus k is here, minus k, so okay, now the constant is, it may be minus, it may be plus, I can add here also constant. Now it will become IL of t is equal to, this is ln, so e power minus R by L into t into e power k or minus k. So this e power k I will assume simply capital A. Now this is the current expression when t greater than 0. But this is A. Now how to find this value? Because we know that IL of 0 minus is equal to already V by R or IL of 0 plus. That means at t equal to 0, this is the value. So V by R, if I substitute A into this is 0, so it is 1 only. So A is nothing but V by R. This is A. So the final expression is V by R into e power minus R by L into t. This is the t greater than 0 IL of t. That means, see, always the source free network, the inductance current is always exponentially decreasing function, because this is e power minus x, right? Why it is decreasing? Because this inductor is initially stored something. Now this resistor is want the energy from this inductor. So inductor now will behave like a source for the resistor. So it is having some initial energy, then it is providing or it is giving to the resistor. That means it is losing energy, its energy. At the infinite time, this energy will become 0, because this, if you substitute t equal to infinity, we will get IL of t equal to 0. So what is the energy? Half into L into I square. So energy is 0. That means it will give its total energy to this resistor, and this resistor will dissipate that energy in terms of heat. Right? Now this expression I can write in a different way. That is like this. IL of t is equal to V by R into e power minus t by tau. Now what is this tau here? Tau equal to time constant. So this is R by L. Right? This is the time constant in a inductor. So if I replace with tau here, so this is, so now there is a reason tau is equal to not R by L, it is L by R. So time constant in the inductor is L by R. So when I substitute here, so I will get R by L as like this. So this is tau is equal to L by R. This time constant in inductor, always remember. This is about the source free circuit and the analysis. Always remember the IL of t should be exponential decaying function. Right? It is like this. And t is here. This is IL of t at initially V by R. But when t is up to, it is increasing, the current will decrease. Right? In the next lecture, we will see the with source. Right? When t less than 0, there is a source. When t greater than 0, there is a source. How we need to solve